All right, let's see if this will work. Hello, can you hear me? Hello. Oh, so can you hear me now? I don't know. All right, we'll see if this works. All right, so today is going to be the introduction to Git. Only have about 7 slides, so we'll be doing a lot of watching me mistype things on the command line and that sort of thing. It'll be hands-on. If you have your laptop, I'm going to put up a link in a little while where you can kind of follow along. That's right. All right. My name's Andre. I'm not sure if everyone knows me, but I'm the dev lead for the PAC contract. We have decided to try to standardize some of the things that we're doing. One of those is our source control. But I guess a quick question before we kind of jump into it. How many people are using source control? I can keep your hand up for a second just so we can see where they're. All right. How many people know what source control is? Awesome. Okay. All right. All right. What is everyone using? Just let me know. Subversion. Anything else other than Subversion? Source save, and I heard something else. RCS. Okay. All right. Cool. Anything else? That is not source control. There you go. You're using Git with an abstraction of TFS. We'll talk about that in a little bit. Okay, cool. So like I mentioned, I only have about 7 slides. We're going to be kind of hands-on as much as possible. Here's what we're going to cover. Basically why we're here. I always like to start off with why, because if you don't care about why, then none of the rest of the stuff actually matters. So as I mentioned, PAC's going to try to standardize. We're trying to standardize our source control. That's kind of like the plumbing side of things. And we're trying to go from there. This will be part 1 of 3 series. Git is a huge landscape. You don't have to know it all to use it. I frankly do not know it all by far. But I have been using it for about 3 or 4 years now. So what are we going to cover today? What are the topics for today? What is Git? Why do we need source control? Why did we choose Git? Because that wasn't just a off-the-cuff decision. And we actually went through some things to get there. We're going to look at Git conceptually. I think that's a good way to go. And then we're going to actually just jump in and start using it. And that's where you guys will jump in with your laptops. And if you don't have one, then maybe pair it with a partner. And I'll be putting it up on the screen as well, but sometimes it's just good to type it out yourselves. All right, and then lastly, we'll look at some hosting tools, hosting and tools as well. So I think I've mentioned there was Subversion, there's Visual Source Save. There was another one I'd never heard of, so we're gonna have to talk about that one later. It'd be interesting to find out about that. But for the most part, those are central source control systems, centralized source control systems, and Git is a little bit different. It's a distributed version control system. So what is Git? Git is free, so that means we can afford it, because a lot of things that are not free, we just can't afford. It's open source, and we'll talk a little bit about what that is, and it's distributed version control system. So again, free because we can afford it. That was actually one of the criteria when we're reviewing it. Say, hey, costs, although we would like to think that it's not a factor as much, we all know that it's very much a factor. And if we're going to standardize on something, we got to make sure that everyone can actually use it. Open source, what does that mean? And I remember talking to one of our senior devs a little while after I first got here, and to him, open source meant that it was insecure. That is not what that means. Generally, for our purposes, it just means that the community works on it for the most part. It has a lot of industry and company backing as well. The version control, so there's a few people that I think, not too many, but a few that said they didn't know what version control is. So basically, it's just we're managing our changes. Computer programs, websites, anything. It's not good for binary files, but anything else text related, That's more so what we're putting into here. Think of it as having a running history of your changes. Who changed it? What did it change from? What did it change to? Those sorts of things, right? As we mentioned, it's a distributed version control system versus centralized systems like SourceSafe, which someone mentioned. Subversion, TFVC, no one mentioned, but that's probably what he meant by Team Foundation Server. That's just, the actual source control part of that is TFVC and a few others. So how is this different from the centralized source control system? With Git, you have the entire history in each repo. So in each area, you're going to have the entire history, all the changes that happen up until the point that you forked off from another repo. But for general purposes, to keep it simple for right now, you have the entire history. There's a little asterisk there because there's always the caveats to that. You can grab a branch and not get to all the other branches. That's complexity. That's like the next either part 2 or part 3 of this. We'll touch on some of that. Okay. Does everyone understand what we have here so far? Because it's kind of core. This will be interactive, so if you guys have questions, please let me know. I'll try my best to answer them. But again, I'm not an expert. Any questions on this? What Git is so far? All right, cool. Like I said, I only have 7 slides, so we're already on slide 3. So why do we need source control? Anyone want to take a gamble at that? Why do we need source control?
So if I make a change, then you make a change, you can see my change part, so you don't redo what I already did.
Yeah, that's perfect. That's a good answer. I meant to actually do the actual presentation thing where you kind of open up these things one at a time so you guys aren't reading ahead, but I'm not a presentator. I'm a developer, so I just didn't get around to doing it. There's a story I can tell you guys really quickly. My senior year, how many people went to University of Maryland, College Park? All right, any developers from University of Maryland, College Park? All right, so you guys are familiar with this probably. There's all the way up until your senior year, depending on which classes you take, you cannot work with anyone, which makes no sense. In the real world, that's not how it goes. But at University of Maryland, College Park, if they assume that you worked with someone, they sat you in a room and you had to rewrite your program from scratch. And if you could not do that, you were kicked out. So what that bred was a bunch of cocky people by the time you got to your senior year. You thought you were the best of the best, the cream of the crop, all that sort of thing. And as a funny, cruel joke, senior year, one of my classes, they push in a group of about 17 people. You've been by yourself this whole time, and now you're in a group of 17 people, and your whole project, your whole grade depends on one project that these 17 people put together over the course of a semester. So by this time, I was a senior. There's probably like 4 or 5 other seniors that were like, we're tired of the school. We hate the school. We just want to get out and make some money. So we were very focused. We had a bunch of other people that were on ski trips, missing meetings, all these sorts of things. They just were not paying attention. They did not care. But guess what? They got the same grade as the rest of us because the teacher said that's how the real world works, right? So we had, out of the, I think, 4 people that were actively contributing to the project. Actually, no, 5 people, because the other guy I always try to forget. 5 people actually contributing to the project. 4 of us knew what we were doing, and one guy was, he got an E for effort, all right, but he did not know what he was doing. So we gave him a project and said, hey, go off and go do this thing, and let us know when you're done. All right, so we're chugging along, 2-3 months in, we're almost there. We're sweating bullets, crying, not seeing our family because it was just so much work. Long story short, this guy comes back in, says, I finished that thing that I was supposed to do. And he overwrote all of our code. And guess what we did not have? There you go. All right. So we went to the teacher, we were crying. Long story short, he said, I don't care. It's your problem. But that's one of the reasons why you want source control, right? You don't want to lose your work because someone comes in and says, okay, I have this version that's 3 months old and I'm going to overwrite your current version, right? Backups help with that as well, but just a little story there. I know For our contract, there are some projects, at least one project, that lost their work 3 separate times. They had to start over 3 separate times because, one, they did not have backups, which I'm amazed and shocked, and I don't know how that happened. But if they had source control, if the developer had source control on their local machine, they wouldn't have had to start over as well, right? So you don't want to lose work. Here's one I get sometimes too. It's like, well, especially for the PAC contract. When I first got here, they said, here's your customer, your code is on that machine over there. Good luck, sink or swim, right? Since I've been here, I've barely worked on a team of more than one. Usually it's just me by myself. And how many other people are working by themselves for the most? A few. Not as many as I would think, though. So sometimes people say, well, I'm the only developer. I don't need source control. I'm the only one making changes. All right, so that's not quite accurate. You're working with at least 2 people. You work with current you, the wonderful current you, the awesome current you that's very ingenious and makes all those wise little bits of code. And you work with evil, forgetful, unappreciated, rushed former you, rushed past you, right? You ever look at some code or look at some script and say, well, who did this crap? And like a couple minutes later realize, oh, that was me, right? But you had a reason why you did that, right? Because current you back then was rushed, or you had a particular reason, but you don't remember what that was. You don't know how you got there, right? So that's another reason for source control. Again, the history of what changed and when, and not only just when, but also why. Why did this change happen? Sometimes we have that in our ticketing system. How many people use a ticketing system, some type of ticketing system? All right, so a large majority of us, but how many people have their ticketing system connected to the actual change? How do you track your changes back to your actual tickets? You know what changed, but do you know what ticket led to what change? All right, yeah. So a few of us, but that's, again, another reason for source control. You want to marry those things together, right? Hopefully from the time that the change was requested down to when it was released in production and all the way back and forth, right? Tying all those things together. So source control can help with that. Changing priorities is another one. How many people have ever heard the phrase, stop what you're doing right now and get on this other thing? How many people actually had that happen to them? All right, so if you haven't had that happen to you, you have to talk after this as well, because you have a sweet job. All right?
The actual code was drop everything, but not everything.
Yes, everything that's not the thing that I'm talking about right now, but the thing that I want later on, don't drop that. And you're supposed to know what that means. Yeah. So changing priorities is another reason for source control, right? You don't want to lose where you are, but you need to go back to somewhere else, right? And pick something else up. And when you come back, you don't want to have a half-baked thing going into production because you were halfway through something and you switch priorities, and now you have that half-baked thing in production, right? Unwittingly. Another one is experimentation, right? You think you have a good idea. It's like, let me try this out. But it doesn't go so well, right? You want to back that back out and get back to a good state. The flip side of that is you're less likely to experiment with things if it's not easy to back that out, right? But if you can easily and cheaply say, okay, I can try something out, do a spike, so to speak, and see how it goes. And if it doesn't work out, no problem. I know I can go back to a good state within a command. Then you're more likely to experiment. You're more likely to find better solutions as well, a lot quicker, right? Because you're not afraid to experiment. And the last one here is the foundation for a lot of other things, right? I'll talk about that in a minute, but get a lot of other automation tools start with source control, right? So, and you'll hear that mentioned a lot when you're talking about infrastructure things, or you're talking about, let me say infrastructure specifically, but infrastructure as code, and automation, automated builds, automated deployments, automatic, well, all those go together. So CI and CD, all those things A lot of that starts with source control, which kind of leads us into, I believe, the next slide. So how do we choose Git? Actually, let me go back. Does everyone understand this? Anyone have any questions about why do we actually need source control? So you guys speak up if you need to. Like, this is a safe zone. That's why the doors are closed, right? And it's dark. No one can even see you. It's okay. All right, because I want to make sure everyone understands this, because a lot of times what happens, myself included, you're in the room with a bunch of people and you feel as though everyone else understands. And you're the one person that doesn't. And that's not true. I guarantee you it's not true. Half the stuff I'm saying right now I don't understand. So it'll be okay. If you feel more comfortable afterwards, come up to me and ask questions. But definitely ask questions. All right. Okay. All right. So how do we choose Git? Everyone know Tara Delaney? So she's came from industry maybe about a year and a half ago, so she's still not quite assimilated into the Guarded culture. She came with a lot of ideas from the outside, and she's like that marriage between IT and business. So she understands somewhat the IT side of things, but she definitely speaks the business lingo, right? Just like, you guys need a task force. I'm like, okay, we need a group of people. You call it a task force or Tiger Group or whatever you call it. Cool. We'll get a group of people together that actually care about this topic. So I'm not sure if you guys remember that we sent out an email and said, hey, who wants to be on these task force? There was 3 of them that were running: documentation, which we still need to get on, source control, and training. So the training one is finished. You should have gotten an email saying, here's how you can get training, that sort of stuff. The source control one, we're kind of wrapping up today, is one of the key things that came out of that. It's like, hey, we need to actually train the people on source control. We need to pick source control. We need to train them. And then give you guys the tools to make you successful as well. So we got that task force together. It was comprised of devs, sysadmins. I think we even have security representation in there as well. We try to make sure we get a nice cross section of different people. Try to get people that were on smaller teams, people that were on, because I don't think we have any really big teams. Single person teams as well, like I mentioned before. Try to get as much of a cross section as we could so that everyone's represented in that task force, right? So what we did is at the very beginning, we listed every source control option we could think of. And that the gentleman in the back that mentioned the other one, I never heard that one. So that one was not considered. But Subversion, Git, we even consider file system, right? Some people say, I do my version control by zipping it up and calling it Tuesday. And while I would not recommend that, we were like, well, we can't just rule it out, right? Because that would not be fair. That would be biased. And we were trying our best not to be biased. So using your file system, CVS, source save, TFVC, ClearCase, Rationale, Mercurial, Perforce, Fossil. I believe there was maybe a couple others. I couldn't remember. But the notes, I'll send this out later, and the notes for our meetings are recorded as well. So you guys can take a look at that as well. We created a list of criteria. We say, okay, what's important? What's important for us to, when picking a source control system? And there was a number of things in there: community integration, security, feature sets, cost, as I mentioned before, complexity, which Git is not it is a complex thing. So that did not count towards Git. History, user interfaces, admin functionality, that sort of thing. As I mentioned, the notes we can find there as well. All right, so I believe we're down to slide 6. So it's gonna be really short, or so you think. No, we're actually gonna get into the meat of it. That is not in the slides. So what is Git doing? Anyone want to take a stab at how Git works? Explaining it without a whiteboard. No, make me work for more money. Okay. All right, so we're gonna take a look at something. If you want to follow along, you don't necessarily need to follow along with this one. This second link down here is the one you're gonna want to follow along with, okay? But we'll come back to that. This one up here is more so the theory of Git. Right? theoretically, what is Git doing in a nice graphical kind of interface. I like this one. Okay, realize you're not coming. All right, so I'm not going to read through all this, but let's say you have you want to get started with Git. Then what would you do? You would basically just go to the file folder that you have your scripts in, or your source control, your source for your application, whatever the case may be, and you're going to type in the command line. Can you guys see that? Should I make that larger? Larger. Gotcha. Better? Good?
Yes.
All right. All right, you're going to go to the command line. I see how many people actually use the command line? How many people hate the command line? All right, that's a valid answer. I was not a command line person. I will say now that I'm still, command line is not my favorite place to be. All right. So we're going to talk about that. For the people that do not like the command line, there are options, and we will explore those. But starting off is, I think it's a good idea to start off with learning Git from the command line, because there are going to be points that if you're trying to do complex Git things, that the UI may let you down a little bit, right? And this helps to understand what the UI is doing for you under covers. They're just executing these commands on your behalf on the command line. Right? So you're going to go to your area. You're going to type in git init, and you're done. Your stuff is now in source control. All right, it's that easy. All right. So what that git init is going to do for you is going to create a folder, a hidden folder most times, called .git, and all your version history is going to be in there. All right. Not something you need to care about, but it's there. All right. So there's no server involved. Right? You don't have to have a server to do this. This is one of the reasons why we chose Git, because anyone can do it. You just need the Git client when you're Git installed on your machine, and you can run that command and you're good to go. All right, so now I actually want to make a change. All right, so I'm going to gloss over some things so people that actually know Git we'll touch on that in the demo. But let's say you want to commit. You want to make some changes and you want to commit that to your repository, your source control. I'm going to use repository for your version control, right? That's how it makes sense in my head. So if you do git commit, that's going to commit your changes to that source control. So now you see on the right-hand side, there's going to be a visual representation of what Git is doing for you behind the scenes. And I think that's the key part. That's the reason why I chose to add this in, because I think it's really helpful. Okay. So we've added online.txt. That's our first commit. You'll see here it says head and there's master. We'll explain a little bit more about what that is. Well, actually, I guess we can explain that now. So head is your current place in the branch that you're in, and then master is just a branch name. Okay, and that's your default branch. That's for Subversion, I believe you call that the trunk. Right? All right. I see nods, so I'm guessing I'm right. All right. So we make another commit. All right, and we just advance from one place to the other. So that previous commit, we can go back to it if we want to, but now we have another commit layered on top of it. All right. And another one. All right. So you see it moving forward. And basically what we're building here is a graph, right? Directed acyclic graph. Is that correct? Yes. If it's not correct, you don't know. So it's all right. No, it's not. All right. So we'll get to the graph part in a minute. So now we just created a branch. We called it my branch. So this is a little bit different from what you have in Subversion, source safe. I'm trying to remember some of the other ones that I've actually worked with before. In Subversion, you're going to create it'll create a whole copy of your file system. Is that correct? Somewhat, right, for your branch. So branches are a little bit more expensive, so you tend to do them less than some of the other ones. But for Git, creating a branch is just creating another pointer to the same reference. All right, so creating a branch is really quick, really cheap, really easy. All right, and it encourages you to create as many branches as you want. There's some cost to that somewhat, but we'll talk about that in a minute. So everyone follow me so far? We have 3 things up on the screen, 3 tags, right? Head, master, and my branch. Anyone want to take a gamble at what those are? We already talked about them, but just want to make sure everyone understands. That is actually a question. Okay, I'll answer my own question. There you go. Okay, all right, cool. That's good. So head is the current place, like the most recent commit, right? That's what head is going to point to. Master is the master branch that we start off with. And then we create another branch. Go ahead, gentleman in the back. I think it is case sensitive. And anyone can correct me on that, but I know I've tried it a couple of times and I've created a branch and then I typed, like I did the camel casing and then later on I did something different and it was 2 branches. Same name, slightly different casing. So yes, it is case sensitive. Right? So let's go down and make another commit. All right, so we made a commit on master, right? Does that make sense? We made a commit on master, so my branch is still pointing back to that previous node because we didn't make a commit on that branch, right? Does that make sense? Oh, okay. It's just for example. Yeah, this is just to understand the. Go ahead.
Normally, you put a file name like Subversion.
Yes, and we'll touch on what I want for this part of the demo, just to give you the high level of what Git is doing. There's a lot more that we're kind of glossing over. We'll touch on it in a minute. So that's a good question. Go ahead, Bill.
Creating a branch does not automatically put you that way.
That is correct. That's correct, right? You can create a branch without actually switching to that branch. And that's more likely what they did here. They created the my branch, and it's almost like you can use that as like a checkpoint. Say, hey, I want to roll back to this known Git state. I can create a branch of it there, and I can always get back to it that way. There's other ways of doing that, and we'll touch on that as well later. But yeah, that's a good question. So they created my branch, but they're still on master at that point. When they made the other commit, master rolled forward, my branch stayed where it was. Cool. All right, good. Like that. More questions, the better. All right. So to Bill's point, now we have checked out master, or we've switched to switched to my branch. All right, so you notice what happened? Head moved from that last node up to back to the other one, right? Because head is the current place, the most recent place in the branch that you're in. That makes sense? Okay. And we've checked out my branch, so now we're on my branch, right? We do another commit, and this is when it starts getting fun. All right. So remember we were on master, we did a commit that was not in my branch. That is this commit here, right? We added another commit that is now this one on my branch, all right? Slightly different. I think just because the graph before was just going straight down, it looks like something weird happened. But just imagine that we're going straight down and another one got added to the side on my branch. All right, same thing. Does that make sense to everybody so far? Yeah. So we were on master. Actually, before we jump back to my branch, we were on master. We created the my branch here, right? Then we added another commit on master here. Then we went back to my branch, which is again up here, and we created another commit on that branch. So now we have 2 branches with commits that are not in either, right? that make sense? Had a question?
Yeah, just I want to make sure stuff for each node represents the whole set of files and plays under.
Yes. Yes. So each node here, you have one file system. I want to make this too complex. Do this instead of pointing up there. All right. So at this point, we had all our files were all the same, right, up here. We made a commit, which let's say added a file or made a change. And now our file system is represented by what's here. Made another one here, and then another one here. When we went back to this branch, our whole file system switched back to as it looked here, right? So these changes we didn't throw away. They're in that hidden Git folder that we mentioned before. So our file system looks like this, right? So if you look at the file system, all you see is one directory as it shows up here. When I made this commit here, now my file system looks like this. Right? And your file system is going to look like the place where the head is pointing.
Not just flat set of files. The whole tree inside the hierarchy.
No, each one of those nodes is only going to have a diff. So it's like layering on different diffs on top of each other. And that's how it does the branching and all those things so quickly. It's not storing a whole copy of your file system multiple times. It's just storing diffs. Thanks, Dylan. All right. Any other questions so far? Okay. All right. So we do another commit on my branch, right? And now that's moved forward again. All right. So now we start merging. I'm trying to remember. I remember merging in source save was hell. I'm trying to remember how it was in Subversion. I don't think it was as bad. But what we're doing here is we're merging, I believe, I didn't read, I'm trying to remember if I read this properly. We're merging master into my branch, right? So we're taking, why do I keep doing that? This branch here and merging it over into this branch, right? So imagine you merged it here and then this was the result of that, those two coming together. Does that make sense? Yeah.
All right, so you merge them. What happens if I want to merge them?
Say that one more time. You want to merge them?
I merged it so that my branch connected to master.
Uh-huh.
So when I do that merge, I wanted to create another sub layer of master.
You want to create another branch of master?
Well, instead of it connecting to master, it'll actually make it flow.
Okay. All right. So yeah, that's just a merge the other way. All right. So imagine you. I think we're going to get to that in a minute, but yeah. And there's a number of there's a few merging strategies. Like right now, we're just trying to get to the basics of it, like understanding source control and how Git works underneath the covers. And we'll touch on, I think, some of the different merging strategies in the second version of this training, which is next Monday. I believe I got to send out the notes for that. All right. So now we've gone and checked out master again. So our head points back over to master. I believe we're going to do a merge the other way. So we've now merged. That changes back into master. You know, this is for like understanding purposes, but I do not recommend this. All right, and we'll talk about a good way of doing your merges so that you don't run into crazy, inconsistent states later on. All right. I think this is mostly to point out that you can merge any branches to however you want. Okay. All right. So, as I mentioned before, Git is distributed, right? So that all this stuff that was happening, we could say that all this is happening on our local laptops, right? So you don't have to have a connection to the centralized server to do commits and move your stuff forward or roll back to other states. You can do all that locally. But at some point, you want to share your work with someone else, right? And to do that, you're probably going to have what they call a remote somewhere else that is also a copy of the same repository, right? But to connect your local repository to that repository, you're going to add a remote, which is what they're doing here. Don't worry about the actual command. We're going to go through the commands in a few minutes, all right? But I just want to show that you're adding a remote, all right? And then we do a push. A push is kind of like what you would consider, I think, a commit in Subversion and other source control systems. So that's taking your changes locally that you had and then pushing those up to the central repository, the remote. I want to say central repository. Your remote, because you can have more than one. All right, so then we did git commit. So actually, I kind of skipped past this. This guy now represents master on our remote, right? It's also another pointer. All these are just like pointers, right? So we committed again on master, and that moved forward. All right, and if we wanted to get those changes down, let's say someone else made changes, and we want to get their changes back into our repository locally, right? Then we do a git fetch, and that'll go and grab all the changes that you that happened since the last time you synced up with the centralized server. I don't want to say centralized server, since you synced up with the remote last. And that'll get those changes down. They won't actually merge them in. That's a different request, different thing. But again, so we're glossing over some of the details here. I'm gone a little bit further. So any questions so far? Yeah.
Okay, so we can go back.
Sure. This one?
Okay, yeah, we'll start. All right, go back one more.
Okay.
All right, so I published this out for the world.
Yep.
Okay. Please go forward. So now anything that I've added to this one means that it is not published to the world.
Yes. Yeah. If you add it to your local repository and you have not pushed it again, it's just local to you.
Okay. So now,
Sure thing.
So now everything that was in the past was after the last publish. It is now published back out into the web.
Yeah, so this guy here represents the changes you made after you publish, right? This guy represents my change that I pushed to the central repository. It's the same repo, but the central one. And that one's, so master has one commit that you don't have locally, and you have one commit that the remote repository doesn't have.
Now, the remote repository, does it start breaking, show version 1, version 2? Or it'll show like Adams and Andres published?
Yeah.
Put it together.
It'll be, think of it as the exact copy of what you have locally. It's no different than the one that you're working on locally, other than maybe it has other commits that someone else put in that you haven't yet pulled down into your repo. Does that,
Okay.
yeah,
Yep.
make more sense? Okay, cool. Actually, did it. Go ahead.
So when you publish it, does it try to do existing file?
No. So if you some of what we'll touch on that in a few minutes. I don't want to jump ahead because then it'll be like you have to explain a bunch of other stuff. Yeah.
If two people are working on a project together and they both publish at the same time,
Okay, that's a good question. It's very related to the gentleman in the back, and we'll touch on that. So one of the things with this distributed version control system, it doesn't prevent you from all working on the same things at once, right? You can work all on the same file in your local system, and you will have no pain. The pain will come in when you start to try to merge those things back together. Git does a lot of the merging for you, But when it can't figure it out, it gives you a way of saying, well, here's what you did, here's what someone else did, and I don't know which one to do. You figure it out. All right. So it won't crush your files most of the time. All right. Good questions. All right. So we've now doing a merge against the one that was on published master, and at this point, it's kind of a new point. That's the end of it for this. And we're going to go into the command line, and we're actually going to try some things out in a few minutes. But theoretically wise, it glosses over some of the details. But this, in general, this graph that you see on the right-hand side, that's kind of what the representation of Git is underneath the covers, right? Each one of your commits, just think of it as another blue dot. When you're merging them, think of it as just a line connecting two branches together. When creating a branch, just think of it as putting another tag in your graph, right? So those are the major concepts I was trying to get across with this graph. Does that make sense so far? Yeah.
Kind of. This is, I mean, the way we've usually done it is there's already a repo.
Mm-hmm.
I pull the repo down to my local machine, make changes, and I'm trying to do it. Is that going to be a different example?
No, it's that same. It's imagine that you start somewhere like here. That's what you're referring to. The Git init part depends on how often you start new projects. All right. Other than that, you would just do a pull, and you would just start at a different point. Maybe you start here or you start there, but it's all the same. Yeah.
The assumption is if you pull them that directory down, you make changes. You don't want to complete it with that as long as you push it back. What happens if you have pushed some changes up to the repo that you decide you don't
want there? Yeah, there's a couple strategies for that. We won't cover any of them today, but we'll do that next week. Yeah. But yes, there's ways of doing that. You can either add another node that reverts the one before. You can say, I'm going to rewrite history, and you're going to screw over other people, depending on if someone else has already pulled that branch. There's some other things. But you can do a lot of things. Just because you can do them don't mean you should do them. All right. Any other questions on like the theory, high-level theory of it so far? All right. Let's jump down into some demos. All right, so you can try to type in this this URL here. Try github.io levels1 challenges 1. Let me know. You guys get there now. Jump in. Any questions while everyone's typing this in as well? Does it all make sense to you guys so far? Yeah.
So it's versioning of your repo, maybe based on time changes and whatnot. If basically it's a large tree, if you get lost in the tree, is there Git resources that show you kind of like a diagram or some kind of package it is or where the changes exist in the tree?
Yes.
So you can look at it from the top level down.
Yes, and we were gonna end up on that, but actually I can't do that because then people won't be able to see it. There's a number of things. Like I mentioned before, I'm more of a visual person, not so much a command line person. I use a command line, but I prefer visual things. So we're gonna look at like Git cracking and a couple other tools that make the visualization pretty easy. I'm gonna switch over just for a second. So this is my repo, right? Shows you how things are moving back and forth. All these are tagged. So this is a branch I call anonymous feedback. This is the same branch, but on master. On the remote. I have an IP address upload branch, local storage branch, Angular branch, and they're at different stages. And so this helps is one of the visual tools that you can use. Actually, one of the nicer ones, I think. And this one shows all the changes, but we'll touch on that. We'll dive into those toolings. That's going to be one of the last things that we looked at. But I wanted to show you guys the command line first so you can kind of get a good understanding of it. And then we'll jump into the tooling. All right. Everyone got the URL so far? All right, so we're going to move ahead. You can still probably see the URL at the top. So I chose this one because not all of us have admin privileges to our box. And I wanted you guys to follow along. So you can actually follow along here without, this is online command line basically, and we're going to run through a few of these steps. All right, so we can create our repo. We can just type in git init. Right. Hit enter. Hopefully your Wi-Fi is working. Oh yes, I can't type. I can't spell. So yes, I did mean git init. All right, cool, successful. Everyone there? Yeah. Cool. So we just created a repo. Remember, like I said, it's that easy, right? We got a folder, create, get init. All right, so I didn't mention this one before, but we can check the status of our repo by typing in git status. So we type in git status, and it's going to tell us. Oh. Actually, I'm going to take that back when we saw that. They're going to be doing some things in between to kind of help us along. So they created a file called octocat.txt, right? And that file is going to show up in a minute. Okay? So after we did git status, it showed us that everything is cool. You know, now they've added that octocat.txt file. And if we type in git status one more time, we'll see something different. So now it's tracking another file, right? It's tracking that octocat.txt file that they added for us. So before I mentioned that there was a commit, and I said we were glossing over some of the details, right? This is one of the details that we're glossing over. So you can have files that are, you have to tell Git which files you want it to track, right? Right now, it's tracking this file, but it hasn't added it to, it hasn't staged it to commit it. If that makes sense. That probably does not make sense. So basically we're saying, it says, I found this file, octocat.txt, and I don't have any history of it. Oh, I'm sorry, go ahead. Mm-hmm.
So if I took that text file and put it in my Git folder, I did the Git add Git status, does it automatically upload it?
Okay, good question. All right, so when you say your Git folder, are you talking about the .git folder? Or are you talking about your, okay, so you won't add anything to that Git folder. That is Git's domain. You'll leave that guy alone, right? You can ignore him, but you're gonna add that folder, that file to wherever your other files are, right? So your normal file system, right? Let's call it, I don't remember what they called it here, but let's say it's Git training demo folder, whatever, right? You'd add that file to there, and Git will say, hey, there's a new file in here. And that's where to show up in red, right? Does that make sense? And then we're gonna say, we're gonna add that file by typing in git add octocat, and because I cannot type, I'm not gonna sit here and type this out. If you wanna be lazy, you can just click the little link at the top, and it'll auto type it in for you. But muscle memory is good, right? You wanna get some muscle memory of typing these git commands in. It'll help later on. But I'm lazy and I'm demoing, so we're gonna take the easy route out. So I do git add. It's gonna ask me to do another git status, right? And you notice there'll be something slightly different here. Remember it was in red before, and now it's in green. It's basically said that file's been staged to be committed, right? Which means like it's ready to be part of a commit. Does that make sense? And then the next step we're gonna commit that. I think someone else mentioned before that you would add a file name or something of that nature. There's kind of two parts to it, right? So last time we told it what file to track, and now we're going to add a message to our git commit. And those messages are important. I'll send out with the notes some tips on how to write good messages, because there's some tricks and tips to that, right, that you want to try to follow. Yes, go ahead.
I was kind of thinking of this, if you're starting new, that whole bunch of stuff in file structure.
Mm-hmm.
So add a little bit of, like, you can do like git add dash a dot the current directory, so and track
That is correct. Yes. Yep. Yeah. Yep, you are correct. And we'll get to that. That's actually in the demo. But yes, you don't have to add every single file. We're kind of going through this. Oh, sorry. Go ahead. No, it's good. I like it.
When I text file that I create, I do the git add and put in the outclasses.txt.
Mm-hmm.
Where does it know where to go? I mean, I could have my outputs. I could have it in
Oh, okay. All right.
test.
Good question. Good question. So when you ran that git init, you ran it in a specific directory. It's only going to track the things that are in that directory.
How do I do that directory? Put that directory.
You're going to be in that directory. So when you go to your command line, let's say, for example, fine.
I do. So,
Okay.
oh, okay.
Yeah. So
Okay, so it's working off of, we're starting from, I've already went to the directory where I have.
Yes,
text
correct.
files.
correct. So say, for example, this is my project directory. Type in CMD. I'm now at this command line. I'm at this folder in the command line. I do a git status here. That's the changes that are in that directory, right?
Okay.
And all the subdirectories below it. But whenever you do that git init, it's going to track that directory and below. Okay? That's a good question. I like that. All right. All right. So we add our commit, our message, right? Into. I'll stop blank on everyone's name. You can do a glob, right? As I think it was mentioned before. So you do git, say add all the ones that end in txt. Right? That'll add that. I'm gonna go. We have about 40 minutes or so left. There's a number of these things that we're gonna go through. So I'm going a little bit faster, but please stop me if anything doesn't make sense. And you'll have this to play around with. I'll put all this in the notes when we go out. But what I really want to focus on here is if there are questions, we can focus on the questions. Okay.
You need to get in it the first time.
Does
it back up and baseline your entire repo in that .git area?
Yes. It's when you let me think about this. When you do git init, it's going to start tracking that file system. I think you have to do a commit, and then whatever's in your first commit, whatever's in your current system now, and you do that commit, that's where it's going to start tracking. Yeah. And I usually just name that initial commit or something like that within the message or whatever you want to say. Most times I think it's just initial commit. All right. So, yes, sir.
When we go to git add, start on text, is that only adding the text columns, not all of our directory all the way down?
All the way down. Yeah. Because Git is tracking everything in that folder and everything below it. Right. So you don't want to have, let's say, for example, my code base here. There's a ton of folders in here, and each of these folders has a ton of subfolders. You don't have to go through all that and saying, add this, add this, add this, all the way down. It'll start affecting how you structure your code, and that's not good if your source control system is dictating how you structure your actual logic or your scripts, or whatever the case may be. All right. Yes, we will get to that. You guys are on top of it. Hold on one second. I'll repeat it. Oh, actually, let me repeat it, and then I'll get Anthony's question. He mentioned about a git ignore. And you can ignore certain files, because some files you don't want Git to track. I mentioned before, like binary files, output files. things that you're going to generate based on the things that you're trying to track, you don't want to put those in your source control. Right? They're just going to be bloat. Every time, let's say you do a build or you run something and it creates an output file, and that's going to be different every time you do your build or your run. You don't want to store that because that's an output. You want to store what made that output. Right? Otherwise, you get a lot of noise in your commits. Anthony.
You want to add objects to your repo that are larger, like images.
Mm-hmm.
Is there a verbose? And that monitor what's being added in real time. Text files are tiny, but if you want to add a picture,
Mm-hmm. Yep, there's two parts to that question. Large things, tracking large files, right? And then tracking the status as it's going. But by default, when you're in the command line, it won't. I think we're only doing like 1 or 2 files. So if you notice here, it said 1 file changed, 1 inserted. It'll output that stuff by default at the command line, especially when you have a lot of changes. You'll see spinners and it'll name out files. The other part of that is for large files. Let's say I'm on a project that's doing VR and AR stuff, and there's a lot of assets that are just big binary files. You don't want to track those in Git by itself. There's another tool that's basically another add-in to Git for large file storage, and you'll track it there. So you just add another command plus that, and then you just commit it normally, but it doesn't go into your repo where all those nodes that we showed before in blue. It'll go to like another file system, but you can interface with it as if it's already in your command in your repo. Good questions. All right. All right, so we're going to add, I believe, another commit message. I mentioned right before, so you'll see down here, you see the files listed out as well. All right. So git log will tell you, it's basically a journal of all the stuff that's happened so far, right? You can run git log. All right, and it shows me my commits. It shows the messages, dates, times, all that sort of thing, all right? Big brother's watching. All right. It's useful though, because then, well, I guess that's next week. We'll get into, there's a bunch of things you can do with git log, automatic things where like, this bug was introduced, but I don't know when. You can run some scripts and it'll bisect the logs and find exactly when that bug was introduced. You can actually say, here's a test case, run it against all these things until you find the commit that this thing was introduced. So it's a really powerful tool. Right. Yeah.
What you were saying before though about Git goes through the entire tree and deletes everything. That's because we're using the Git RM command. We can do stuff in the file system with the normal rules, then just commit the tree.
Yeah.
Okay, so we don't have to worry about that.
Nope. Oh, good question. And I think we're going to touch on Git RM in a little bit as well. All right. So I mentioned adding that.
In general, what it sounds like though is that there's no penalty for when we create our own branch. Mm-hmm. Tiny check-ins to that local branch. Mm-hmm. We don't have to worry about clogging that up. There'll be one merge to the master that'll get everything together, so that we don't have to make that decision between doing a small commit or a big commit.
That's a good question. Let me answer that in multiple parts. So, sorry. Correct me if I'm wrong. He was asking about there's no penalty for making a bunch of smaller commits, because when you merge that back in, you'll just have like, it'll kind of squash it down and make that nice commit for you. Yes and no. So there's definitely no penalties for smaller commits. Matter of fact, that is encouraged, right? Commit often is kind of the thing they're saying. Every small change, every relevant small change that you would want to roll back to, I would commit. And that, as you get used to using source control and using Git in particular, you'll commit a lot more. You know, one file here, one line there, whatever makes sense to you, right? Actually, you just start doing a lot more because it's better, because then you have all these points in time you can go back to. Now, when you merge that back in, by default, if you just do a merge, you'll see all that history as well, right? That history will still be there. You can kind of see it here. Each one of these things going back in is a merge, but I still have all those. When I created the branch and I went over here and I did 4 commits on this branch, or however many this was over here, all that's still there, and they're all points I can go back to, right? Some of the merges, not too many of them, you can take all these merges, all these commits here, and say, I don't care about how I got here. I just want the end result, and you can squash those down to 1 commit and then merge that back in. You can do a bunch of other things too as well, but a lot of those things are going to be in the next week or the week after.
Once you squash it, open it back up, and later you realize.
No. So when you squash it, you're more or less changing the history of it. All right. You're saying I don't want to say it's a bad thing. It's kind of, think of it in terms of you can call it I don't know.
Make a clean history.
Yeah.
Yourself.
Yeah. So imagine think of it as writing a story, right? Let's say you wrote the first draft and it was kind of rough, and you went back and you want to revise it and make the story a little bit cleaner. You can do that with Git. You can say, okay, I had these 6 commits, but really it's 3 different commits. I want to pull these 2 together and these other 3 together, and there's one last one, and I want to put messages on those and make that my history. And you can do that. And we'll touch on that next week, I believe, with rebasing, interactive rebasing. But you don't need to know any of those things to use Git successfully, right? That's more a slightly intermediate to advanced topic. I don't use that very often, as you can tell from my history, because it's cheap to have branches. It's cheap to have branches, and it's cheap to have commits as well. Only when I have something in there where, like, it's totally screwed up or something like that, or I was playing around with something that I would change the history or squash things down. Some of it just depends on your style as well. All right. So adding remote, actually, before I put my head down, any other questions? Did I answer the questions that were posed, I think? Okay. So adding a remote is basically git add remote. Origin is the default name for your remote, but you can have multiple origins. You can have multiple remotes, right? And I'll show you an example of that. Hopefully we'll have time as well, all right? So that command adds my origin. That's done. Then we want to push our changes up to that origin. Done that. The dash U there, I believe, is going to, actually, it's right there. I think it has something to do with the parameters, yeah. So like when you do your logins and all that sort of stuff, where like, here's my origin, that sort of thing. If you do that dash U, it's like you won't have to put those things over and over, right? So sometimes it's one of those things where you do it by default, and sometimes you don't know why you do it. You just kind of did it. But that's why that dash U is there. You don't have to have that there, just that you'll have to do things over and over. Any questions so far? Okay. All right. So we've pushed all those things up to master on the remote. Now if we wanted to pull those things back down, remember before we had a git fetch, but I said that git fetch won't actually merge those changes in, right? It will say, here's all the changes that you have to pull in, but a git pull will merge those changes in to your current branch, into your local repository. Does that make sense? Cool. All right. All right, so we can do a diff on where we currently are in the head branch, right? You can do a diff on any 2 points in the branch and any 2 points in your repo as well. If you have the hash for either one, the commit ID, you can say git diff by this and the other one, and it'll create a diff for you, so you can see exactly what changed from one commit to the next. So again, we're just adding a few more files. So and then we do it. So you can, remember I said before also that you have files that you can have files that you stage to commit, and then you have files that you actually commit, right? And those, when you're first starting off, especially depending on what tooling you're using, they might abstract that away, where you just do a commit and it'll stage it and commit it all at the same time. But there is a difference in between there, just in case you want to say, I want to track this thing where it is right now, but I'm not quite ready to commit it yet. You can stage it and then keep working on it, and it'll be a diff between the one that you staged and the one that's working. And I know it sounds complicated, but I think it's more useful when you see some of the UI type stuff. And we'll touch on that in a minute. All right. I'm going to run through some of these pretty quickly. So get reset. I screwed up. I want to go back to this other point. Just do a get reset, and it can clear out those legal changes that are not committed. So that'll change out the changes that are not committed, but not the committed changes. Get checkout is just gonna yeah. So that's going to get rid of all the committed changes since all the changes since the last time we commit, right? And within that current branch. Again, a lot of these things you probably won't ever have to do. When I say ever, you won't do very often. Get branch cleanup is just creating a branch called cleanup, clean_up. And then remember, I think Bill mentioned it before, you can create a branch without switching to it. Checkout is going to switch us over to that branch. Okay. All right, so someone mentioned about removing files from the history, right? So get RM, it's going to remove everything that ends in TXT. Then we want to put a message in there so we can commit that change, right? Because even deleting files is a change, right? So you have to commit those as well. Like, why the heck did you delete the files? Saying, just to be evil, I guess. I don't know. All right. And we can go switch back to master. I'm going kind of fast because I want to show some of the other parts too as well. All the notes, and you can kind of step through this, and there's very good descriptive information at the top. You can kind of breeze through that later. But if there's a question right now, stop me. All right. I'll check up every so often. So then we're merging those branches. We're in the master branch, and we're going to merge cleanup into that branch. Okay. All right, so we've done that. We're deleting that cleanup branch. All right, and we're pushing that change back up. Notice we don't have to do origin and all the other stuff, right? We just do git push now because we did that -u before. All right. All right. All right, cool. Any questions so far? I know it's a lot, and most of it you won't need. But go ahead. Yeah, that's a good question. And we're definitely going to touch on that. And that's part of the reason I was trying to rush through some of those other things. Because having a remote is useful. There's a couple options for that, depending on what you're going to be putting in there. And we'll touch on those in a minute. Please remind me. Actually, we should touch on it regardless. But if I don't answer the question with the rest of the stuff we're going to show, then bring it back up. I think there was like 2 other questions I said that we'll touch on later, but I can't remember what they were. For those people that had those questions, did we touch on your question so far? Or can you remind me what it was so that we can make sure we cover it? And if not, you can just come with me afterwards and we'll do that. All right. So everyone understands so far? I mean, I know you're not going to remember all the commands after seeing them like very briefly, but the major one, go ahead.
It seems real similar.
Mm-hmm. So I think the main difference is going to be how the branches are created. Like they're lightweight, so you're going to branch a lot more. But the bigger one is going to be the fact that it's distributed versus centralized. So you can do all of your stuff for the most part locally on your machine. It's only when you push or pull are you interacting with the remote. So you can do a lot of things. And the merging, I believe, is a little different as well. Yeah.
So, I'm not trying to sound facetious.
Mm-hmm.
What is the difference of using this
Mm-hmm.
and if I had a Windows server, that folder, and I was disciplined enough to name it version 2?
Yeah, yeah. That's a good question. And that's one of the reasons why we had the file system thing in there where we're doing the consideration of the changes, because depending on how, what you're used to or how big of a thing you're doing or how quickly, how often it's changing, those can all be valid solutions, right? To using it. Ted, you want to answer? Okay, go ahead.
A couple things that you get out of using a product like this instead of just using a file system. One, you get the option to have a history of everything that's done. It keeps a transaction history. You also have the ability to make comments in your history about what each version is without having to create like a document file or track everything. There's a lot of automatic tracking going on. And it's also easier to find out if you're putting the comments in, it's a lot easier to say, oh, I'm going to go back to the version that had this clause in there and go back to that branch and branch again off of that. One of the things is you're able to track multiple branches, whereas files, you end up having to mentally keep track of when version 1 and 1A and 1B and 1AA and so on.
Yeah, that's a good point. So let's say you had 3 files and you tracked them version 1, version 2, but they interacted with one another. And this one is at version 1, this other one's at version 5. Do they go together? It's hard to say, right? You have to, go ahead.
I was going to say the other thing is it in a theoretical environment where you are disciplined, there probably might be no difference. But there's a reason we put automated backup software on our computers rather than just give everyone a thumb drive and tell them to back themselves up.
Yeah.
I think the difference occurs when you don't have the time to do it or you're in a rush.
Yeah.
But the automated system, the automated gatekeeper, make sure that those changes occur in a consistent fashion.
Yeah, that's
I
a good
think
point.
we've all seen those folders, new version, new
final.
Exactly.
Really, this time is really his final. Yeah, that sort of thing. Yeah. Yeah.
We had a gentleman in one of our systems who discovered it because the web interface allowed him to create files with stars in the file name, that he used stars to indicate how new something was. So when he tried to pull data out of it, that was just his shortcut, was he just used stars. So
yeah, and that brings up another point too, is like standards are going to change from group to group and person to person. One of the reasons why we're trying to do this and standardize across Git is if I switch from one area to another, I don't want to have to relearn your plumbing, right? Or learn your nuanced things before I can get started actually being productive into the code base. So you can do it with a file system. I would encourage you to try out Git and see if it, yeah, it'll be better. It would. Yeah. Yeah, and the sharing part of it too as well. We didn't really touch on that yet, but that's a big part of it as well.
Actually, just occurs to me the biggest thing is Git won't allow you to clone stuff.
It will.
I think what I'm saying is when you just do a check-in,
yeah.
Everyone's done that thing when you drug the file from the destination to the source rather than the other direction because it was Friday night. It was like the check-in doesn't have that option.
Yeah.
It also gives you support. Which files you modify or not.
Yeah.
The Git status is which file which will be modified. which ones you have to commit.
Yeah. So I'll put Layton on blast here for a second. Go ahead.
I understand this right, but another big advantage is you have much more efficient disk utilization.
Yeah.
Goes to another batch of the same file.
Mhm.
Then you're using a lot less disk space.
Yeah, indeed. And all that whole history goes with that folder. You zip it up and move it somewhere else. That whole history went with it. All right. There's another one too. Layton, I'll put him on blast. We're using Git. We've been using it for a while in conjunction with TFS. When you said TFS here, is in conjunction with Git, right? Someone asked them, I guess, like, when did this change happen? I'm like, I don't know. Tracked it down in Git, found the work item, then found the commits that this was related to, and said, here's when it was asked for, here's when it got started, here's when it went through review, here's when it went into production. All right? You don't have to keep all that in your mind. You just find it when you need it. All right?
When you're going through that cleanup process
Mm-hmm.
and removing say files and you push it, are you at risk of losing some of your versions at that point?
If you merge that change back in and then you delete the branch, you're just deleting a pointer.
Okay.
You're not actually deleting the commits that went along with it. You can shoot yourself in the foot. Right? You can lose stuff. I don't want to say you can't. You can. You just have to work a little bit harder to do it. But if you stay on the happy path, so to speak, someone else mentioned this, and I said there's branching strategies. If you try some of like ones that like I think we're going to go over. I still don't know how we're breaking up the other two sessions, but in one of the future sessions, we'll talk about Git flow and GitHub flow, and how, depending on your team size or how you like doing things, you may like one or the other. There's a couple other branching options as well, but usually like the one we use is GitHub flow, and it's like a circle, right? As long as you stay within that circle, like you commit here, commit, push that up to master, merge at the origin, and then pull down the changes, you have this nice continuous flow. You don't run into any merge conflicts or anything like that for the most part. Right? And we'll touch on those coming up shortly. But I wanted to show what this looks like in real life. I have some changes here. So this is TFS, not TFS, I'm sorry. This is Visual Studio. And I'm going to show you a couple of different tools. Is one I use. So in my IDE, this is my IDE, a lot of them have built-in Git integration. And I mentioned before, you have all the stuff we looked at was on the command line. This is what the IDE is going to do for you, but it just makes it a little bit easier for the most part, some of these other tools, especially if you're a visual person, right? So this shows me I have 3 changes that are current. I can look at those changes. I can look at a diff of those changes. So this shows me the lines that I changed, right? I changed that line there. I changed that line there. There's another thing, getting back to that file system versus source control. You can actually see the lines that are changing, not necessarily at that file change, right? Because the file change, depending on your coding strategy, your file may be 10,000 lines long. Right? Don't recommend it, but yeah, some people it may be that way, right? So I can see exactly which files change here. Sorry there. I can see which files change in all these other ones as well. So those are the file changes there. My commit messages go here. So I don't remember what this change was, but it's okay. I think I was adding unit testing. I can relate those files to a work item. We won't do that right now. We'll touch on that another time. But actually, before we do that, remember I mentioned you can commit or you can stage them, right? If I hit commit all here, it's going to bypass that whole staging process. It'll stage it and commit it all at the same time for me. But if I wanted to, I can go in and stage this one file, and it'll stage that one file, right? You notice it's up here and the other ones are down here. Let me see if I can go to that file. Let's see. If I were to do something like this, save that. You notice this happen? So this file here is still at that point before I added this comment. But now it's also tracking that comment that I just added. Right? And we don't really need that, so we're just going to do, well. Undo changes, all that's gone. All right. So, and then we're just going to go ahead and commit this one. Actually, we'll commit all of them. So I stage all of it now. I can unstage them easily just by clicking that. So now they're all unstaged. Oops, sorry, I didn't do that. All right. So the UI is just, under the cover is just doing git add these files, git unstage these files, right? This is the command line thing. So I staged all those changes. Before today, I had 3 other commits that I made. And you can see those commits here, right, with the message corresponding to them and my little thing. It tells me when I did it, 3 hours ago, 5 hours ago, just now, right? So that's TFS, but let's look at another one. That's actually, no, it's not TFS. That's Visual Studio. You can get that on your Mac or your PC, but generally, most people are Windows people when they use that. Visual Studio Code is also cross-platform. This is the same project. It showed up in a different area. I believe it's the same project. Yeah. All right. Oh, crap. All right, let me do this. I meant to show you guys this one first, but let's do feedback. That. Okay. All right. One of the things I wanted to show you with this one is that one of the features I like with Visual Studio Code, you see how these guys turned orange? It's telling me where the changes are, where the active changes within my file structure are, which is really useful to have. Of course, you're going to see the same changes here. Again, this is the built-in Git integration. I think it works with some other ones, but it's basically based on Git. Again, my changes are here. You can actually stage individual lines at a time as well. You don't have to say I have a file that has some changes here, some other changes here, and they're not really the same thing. You know what I mean? And you can commit the parts of the file that you want, and then commit the other parts later. Right? So it can be as granular as you like. All right. Any questions so far? Okay. All right, so I'm gonna undo these changes because frankly I don't want to litter my code base with that. So I can do, let's go over to command line now. So I do a git status from here. All right, so everything's good. Let's do a git push. I'm gonna do a git push, git see if I remember my password. All right, so what I did here, can you guys see that? So I think to Anthony's question, you see that the output that was coming up here as I was going through it. There's a number of changes there. I did a git push and I added in GitHub here. I have a couple remotes to my repository right now. Let's see, git remote. I have 3 of them. I have a GitLab that I push to. I have a GitHub that I push to, and Origin, which is my TFS server. But I can interchange between all of them. Let's say tomorrow they say they're no longer using TFS, so I can just take my Git repo and I add another Origin and push it there, and it's just like I was there the whole time. All right, so it makes it nice and flexible, right? So let's also push to my regular Origin, and there it is. All right, so all these changes as well. I should have showed you this before I went over, but now all those changes were on this anonymous branch. You saw where this commit message that we just talked about. That's there. Here are the files. Here are the changes. Again, so this is a different tool. This is Git Kraken. It's a cross-platform Git tool, GUI, right? So that's there. All right, and the push commands, branching, all that stuff is also there as well. So the question earlier was about the origin. So I pushed up to, this is TFS, this is one origin that I have. This is my main origin, the one called origin. And if I were to look at my branches that I have there, I have these 3 branches. I have master branch, I have key contact images when I added some images or something, and I have anonymous feedback branch. This shows me that this branch is 1 commit ahead of master and 10 commits behind master. All right. This one is 9 commits ahead of master. All right, so I have 9 commits in my anonymous feedback branch that are not in my master branch. All right. And this guy has 1 commit that's not in master, but it has 10 commits that master has that it doesn't have. All right. And we can compare, we can look at and compare each of these branches. One of the ways you're going to probably end up doing this, and we'll touch on this more in the next couple of times, is you're going to create, you can create a pull request, which is basically like, here's a request to merge this code in. And that's where you can do your sanity checks, your code reviews, that sort of thing. That's what we use ours for. You can also have gates and things in there that says, okay, this can only get into master if so many people are, let's say Greg's the boss, and as Greg signs off on it, it doesn't go in. Or Chris is our security person, and that this part, if we're changing this part of the code, he doesn't approve it, then it doesn't get merged into master. So you can have these gates to keep your master branch pristine, right, and in good condition. So this will show the diff for that file, or for that commit. The commit being, I'm sorry, for the pull request, which is the number of commits. So again, this is the commit we just did a few minutes ago, 6 minutes ago. And there's commits that happened on the 16th, 6 hours ago, 5 hours ago, 3 hours ago. Like I said, you want to commit often. I would have committed a lot more, but I was trying to save this for the demo so we can actually do it here. But I tend to commit like every time I get to a point like that looks good, commit it, put a message on it. And you can always squash it down later on if you want to. So that is TFS, but TFS you have to pay for the most part. Let's look at another option. We have, how many people know about developer.nasa.gov? Not too many. All right. So that is Git. How many people have heard of GitHub? Far more. That is GitHub, but it is a copy of GitHub hosted internal to NASA. All right. So all you need is a NAMS request for that one. I believe it's GitHub Enterprise and NASA thing. When I did a git push there, it pushed it up to this repo here, this remote. Let me see if I can find it. I think we got about 1 minute. Fine. All right, so that's me. All right. So if I were to do a pull request, let's say we do a new one, and we look at that anonymous feedback branch, compared to master, let's see, master to feedback branch. All right. So remember those commits that we did before? There's a bunch of other ones in here because I haven't kept master up, but all those are here as well, right? So I have my one repository locally, and I can push to multiple origins, right? There's also, so that one you can all use if you want to test it out and play around with locally. You can use GitHub if you're just doing some, like you just want to play around with Git, you want to have an origin, and it's nothing, I guess, sensitive, not work related, that sort of thing. Then by all means use GitHub, which will be exactly this, but more up to date. If you have work related things, you don't have another place to put them, I would recommend putting it here. I created an org here for us as well, so we can control access to our area. We can have multiple projects below this org. But at some point, the goal is that we'll start sharing things across pack, right? So we can put them in this org. If you start off with them somewhere else, not a problem. Like I mentioned before, you just have another origin, and you just push it there as well later on, right? Come to me and talk to me about it afterwards if you want to learn a little bit more about that one. GitLab is another popular one. I believe, Chris, your group has GitLab, right?
Yes.
Yep. So there are,
It's a shared resource for GitLab.
Yep.
So it's hosted under IPD. And integrated. The permission stuff has to still be done manually. We create managed workflows for all projects. For all projects that use it. Managed workflow. And then
yeah. So I'll get the link for you for that one because I didn't have it before. 580 also has a GitLab instance as well. So is there a question? No. All right. So 580 has a GitLab instance, so we can see what it looks like. So this is again my same project. This one is on GitLab. So there are the changes. I didn't push the most recent branch there, but you can see there's 893 commits here. There's a bunch of stuff in there. Really interesting too. Let's say you go around to review time, right? You say, hey, I want to do this Git thing. I want to be more active in the community or whatever. Or like one of mine was like, hey, I want to participate in code reviews because that's one of the default ones, right? And later on, you say you're speaking with your manager. You're like, well, how much did you contribute to that sort of thing? You can just do a query on this and say, okay, I committed 543 times, and I participated in this amount of code reviews and this amount of things, all from just pulling up the metrics of what you've already done, right? I think it captures some metrics for us as well. I'm trying to remember exactly where they are. It's been a while, so I know in yes, is this developer? Okay. Graphs. Always kind of make you feel good. Yeah, so this is my commit graph. You can see how much I committed over time, which is pretty cool. Next, I think none of us are non-IT managers. I don't really share this with managers, but it's nice to know for your own personal thing. Otherwise, they start gaming the system, like, oh, you haven't committed. People start committing letters at a time. Like, so we don't want to game the system, but it's nice to know like little things about yourself, that sort of thing. It goes down like how frequently do I commit? When do I commit? Oddly enough, like what time of the day do you commit? That sort of thing. Nice to have, just so you know, little things. I think even you can have if you connect it to your bug system and you do some correlation, you say, oh man, most of my bugs are from commits at 1 o'clock in the morning. I probably should stop coding at 1 o'clock in the morning. You know, just useful things like that. So, all right, I think we are about 3 minutes over. Like I mentioned, this is the last slide. I'm going to add in the 490 resource as well. And we tried to record this. So I'll also put in the recording as well to say, okay, that. And we have three, there's going to be this part one of 3 parts. A lot of the questions like, oh, yes, you can do that, but we're not going to cover that today. Oh, yes, you can do that thing, but we're not going to cover that today. And that's why we had 3 parts to this series. The next one's going to be more of an intermediate. This one's more of a get you introduced to Git. The next one, we're going to talk about some of that Git branching strategies and a few other things. The other one that I mentioned before about like Git bisecting, where you can kind of go through and say, when was this change introduced? I don't know which commit it was. Find the commit for me. We'll probably touch on one of those as well. And then also we'll talk about, again, I mentioned that this is plumbing. So what does this enable us to do on top of that? And that's really the goal of this. It's not source control. Source control is important, but it's what source control enables is what we're aiming for. And so that's what we want to focus in on. Okay. Any questions before we wrap up? All right, so there's a sign-in sheet. Please make sure you guys sign into that. And we'll see you guys. I believe the next one is on Monday, next Monday. but I think it's at like 10 o'clock in the morning or 11 o'clock. Same room, and we'll try to schedule the third one after that. All right, thanks everybody.